So I've realized that you actually want to run the simulation for 10 seconds. In addition, you want to label all your signals. So Y and Y ref here, and then V and V ref. Once you've done that, then you can just click run, wait for it to compile and get your results. Fortunately, the simulation is quite slow. It's high fidelity simulation, so it's a bit difficult to fully optimize. Since the scenario is actually pretty simple, you're just driving straight. Once the compilation occurs, simulation completes fairly quickly here. So now we can just quickly examine our results, visualize our Y versus our Y ref. The error magnitude is pretty low, 8 millimeters over the course of 10 seconds. But it is oscillating and doesn't really seem to be coming down to 0. So it would be nice that even though the error is quite small, it would be nice to see it converge back to 0 a bit more. Now if we look at our other control signal here, V versus V ref, this is pretty much as ideal as you can get it. It comes up, nice sharp bend here, goes pretty small steady state error. That's a success. Now when you have this Wi-Fi enabled icon here, you're actually logging. That means you're logging as well to your workspace in this variable called out. Double click that and go to logs out. You'll be able to see all your signals, and because you labeled them, you know which one's which. So now I want to plot this signal. This is the deliverable now. So if we look up here, this is out.logs out. And then if we want to get Y, right, this is out logs out. And then in curly brackets there, 3. So Y is equal to out.logs out. And then curly bracket 3. And then we can just copy paste this. 1, 2, 3, 4. First one is Y ref. Second one, V ref, Y, then V. Then we can name this extract data. In the second part, we can plot data. So here we can go figure 1, plot. And I've realized that we do also want time, right? Now, notice here that this one, Y, we can't just extract here. We have to do a dot values, dot data, values, dot data. And that's the actual data we get. And I think values dot data. Gotta be careful here to make sure we're actually extracting what we want. Here, double time series likewise for vref and yref. Oops. Yeah. So we want to have this dot values dot data for all of them. Right, but in addition, we want to get our time. And the way we can do that, sorry, T out, look at that. out.tout. If I'm not mistaken. That is our time. And so now when we plot, we can just do t y ref. And then we type hold on so we can plot another curve. Plot t y. We can do an x label time seconds, y label, in this case y, so displacement in meters. So check the time here. And then we can do a legend to differentiate between the two curves, y ref as well as y. And that's the first figure done. You can copy this and do it for the same with the second figure. V time, and now it's velocity in meters per second, and then v ref and v. We can save this in desktop, deliverable. Go to editor here and run this. Yes, change the folder. Hopefully we'll get figures. So you can see that we've plotted the reference signal quite well here, but not the reference, we've plotted the actual signal quite well, but the reference is not popping up. I just copy and paste this one more time just to double check what's going on. Yeah, okay. We're not getting the second. So if we look at our variables here, it must be that, yeah, if you look at vref and yref, they're just a single number because they're constants, right? So to be able to plot that, I think we want, what is it, like a y line? Y line. So now I can show you how to use MATLAB. Help y line. Not like that. Yeah. So if you do that, values creates constant lines that specify values of y, right? So you don't even need to have a time component to this. You just say, this y, do this line. Right. So now we do the same thing. There you go. You have your y ref and y. And the problem here is that underscores meant to do something different for MATLAB. Y line, vref. There you go. Yeah. Yeah, both plots here are now doing exactly what we did in the simulation, but now this is a programmatic thing. It can do it automatically for you instead of having to set up the plots yourself, which is a huge advantage. Right, so that is all. Final thing here is you can go here and save this as a PNG. You can save it as a PDF, a TIFF, so a number of different. You can also go file save as. You can save it as a fig if I want. Yeah, MATLAB figure, which is really cool. Yeah. Anyhow, that's it.